Now I'm going to, in the remaining, I have two more remaining sections in this presentation. I'm going to explain give you some information about the diagnostic tests, which I will enjoy, I suppose, because it is directly relevant to your daily practice. I start with this question. What is the diagnostic threshold for fasting blood glucose in diagnosing diabetes? You are medical health professionals and you are supposed to diagnose diabetes. Of course, unfortunately, many people have diabetes. What is the threshold blood glucose in milligram deciliter, let's say? Check it if you don't know. If you know, then I congratulate you. In milligram deciliters, the threshold is 126. Why they selected this weird number, 126, not 130, not 110, 126. That's the purpose of now of my presentation here. Because using this threshold, we diagnosed diabetes with a sensitivity of 71% and a specificity of 93%. What is this? What is sensitivity? What is specificity? I will explain it in a minute. Okay, if you have, once you have this information, 71 and 93, how would you expect false positives and false negatives? Are we going to have some false positives? Yes, of course, we will. From the sensitivity means from those who have the disease, how many we are going to catch. From 100 who have the disease, I will be able to catch, with this threshold, I will be able to catch 71. So that means 29 I will not be able to catch. They will be having diabetes, but I will not be able to catch them. That is false negative. And then I have specificity means those who have no disease, who are healthy, how many of them I'm going to label as healthy. From 100, I will be able to label 93 as healthy. That means what? 7 people I'm going to falsely label as having the disease. So there are false positives and false negatives, unfortunately. And these are the formulas for sensitivity and specificity. Very easy. You can think logically and try to find. Always draw this four cell table, 2x2 table, and then think sensitivity means from those who have the disease, somehow you know who has the diabetes. What is the gold standard for? You need a gold standard, of course, to know who has the disease. The gold standard for diagnosing diabetes is nowadays, I think, oral glucose tolerance test, isn't it? So by any means, you know actually who has the disease. And from those who have the disease, sensitivity means true positives divided by true positives plus false negatives. Specificity, on the other hand, is about the healthy people. From those who have been proven by a gold standard, you need a reference standard or gold standard. You can call it also reference standard. You know they are healthy. And from those healthy, what is the proportion of the test returning negative? This is in this case true negative divided by true negative plus false positives. Okay, and you should also, what you should know further, you should also know that these two are inversely related, sensitivity and specificity. When you try to decrease sensitivity, you will increase specificity. When you try to increase sensitivity, you will decrease specificity. So they are inversely related, and that is also very easy to understand, I suppose. No? If you have 126, the threshold, you have this proportions, 70 something and 90 something sensitivity specificities. Now imagine you decrease the threshold. You start diagnosing diabetes instead of 126 by 120. That means you will have a lot of more people labeled as diabetes, and that will cause, of course, increase your sensitivity, but on the other hand, decrease the specificity, because some healthy people will be falsely labeled as having the disease. There is a study on this showing the trade-off between sensitivity and specificity. Here you have the blood sugars, you see. If you have a very low blood sugar as threshold, as diagnostic level, cut point, then you have very high sensitivity, of course. If you increase the threshold, the cutoff, then you will have a better specificity, but your sensitivity will be decreasing. So, okay, so this is decreasing, this is increasing anyways. Therefore, what they did, they selected a cut value somewhere in between, which is having the optimum threshold, the optimum between sensitivity and specificity, and there are formulas for that. Good. Another break to make it in short pieces. Stop recording.